This video explains capacitors and direct current, and how capacitors behave when connected to DC sources. A capacitor is a passive electronic component that stores electrical energy in an electric field. It is made of two conductive plates separated by an insulating material called a dielectric. When a voltage is applied across the plates, electric charge accumulates on them, and energy is stored in the electric field between the plates. The ability of a capacitor to store charge is called capacitance. Capacitance is defined as the ratio of stored charge to applied voltage. It is measured in farads. Capacitors store energy temporarily and release it when needed. Because of this property, they are widely used in electronic circuits for energy storage, filtering, timing, and voltage smoothing. Capacitors can charge and discharge. During charging, charge builds up on the plates, and the voltage across the capacitor increases. During discharging, stored charge leaves the plates, and the capacitor voltage decreases. Now consider direct current or DC. Direct current is an electric current that flows in one direction only. Examples of DC sources include batteries and regulated DC power supplies. In DC circuits, the voltage polarity remains constant over time. When a capacitor is connected to a DC source, its behavior changes over time. At the instant the circuit is connected, the capacitor is initially uncharged and behaves like a short circuit, allowing maximum current to flow. As charge on the plates accumulates on the voltage across the capacitor increases, and the current in the circuit decreases. After a long time, the capacitor becomes fully charged to the supply voltage. At this point, it behaves like an open circuit, meaning no steady state DC current flows through the capacitor. Therefore, a capacitor blocks DC after it is fully charged. If the DC source is removed and a conductive path is provided, capacitor discharges. Stored energy is released, and current flows in the opposite direction until the capacitor voltage becomes zero. The speed of charging and discharging in DC circuits is determined by the time constant tau. Tau equals resistance multiplied by capacitance, or R times C. After one time constant, the capacitor reaches about 63% of its final voltage. After 5 time constants, it is considered fully charged or fully discharged.